There are many of the activities and experiments that are going on board the International Space Station that are actually aimed at getting us human beings ready to expand human exploration out into deep space. The International Space Station is NASA's springboard to the exploration of asteroids and eventually to Mars, and NASA is actively preparing for those missions right now. In fact, today underwater out at the Neutral Buoyancy Laboratory here at the Johnson Space Center, astronauts Stan Love and Steve Bowen are trying out some of the tools and techniques that we would use to explore an asteroid. They've agreed to take a few minutes right now to talk with us about what they're doing. It's our first underwater interview from the NBL. Good morning, gentlemen. Stan Love, can you hear me?
Loud and clear. How do you have me?
We've got you 5x5, Stan. Would you start by explaining to us what you guys are doing down there today?
Sure. We're doing two main things here. First of all, we're working on the techniques and tools that we might use someday to explore a small asteroid that was captured from orbit around the sun and brought back by a robot spacecraft to orbit around the moon. And when it's there, we can send people there to take samples and take a look at it up close. So that's our one main task. We're looking at the tools we'd use for that, how we take those samples. The second thing we're doing is testing whether an upgraded version of our bailout and survival suit, basically similar to the one we used on the space shuttle, can work as a full-blown space suit for doing spacewalks.
And that's the suit you're wearing now, right?
Correct. That's the orange. It's called a modified ACES suit. And if you remember all the footage you saw of shuttle crews marching out to go strap into the space shuttle wearing those orange suits, that's this suit with some important upgrades.
For example, what's different about it other than the color?
The color's still the same. Its life support connectors are completely different. It's also been modified so that it fits us more snugly. It gives you a little bit more body mobility, and it's been biased to put the arms in a better working location for working in zero gravity.
Steve is there behind you. Can you tell us a little, Steve, how working in this suit and on this sort of a project would be different than the kind of tasks you've done on 7 spacewalks on the space station?
Well, when you are working in the EMU, it was designed to operate in space and to do those tasks. And so 2 other upgrades to these suits, the gloves and the boots, are both from the EMU. So they help with your ability to do work. And originally, Orion was designed without any EVA capability at all. And the crew office and some others felt very strongly that we needed to have a contingency capability. And so the idea of doing an umbilical spacewalk in the suit you were launching and landing in, ACES at the time, came to be a concept. And so once we tested that, we found that we actually had better mobility than we anticipated. Still have a long way to go to get any real useful mobility. And as far as what we will be able to do in this suit, we just don't know, because it needs some significant modifications to make it easy to translate. As you can see, I can't stretch my arms out quite as far as we used to in the EMU, and the work envelope is very small. It's hard to go all the way across. So as we get through, as Stan said, as we look at these tasks are outstanding to help us develop what needs to be modified in the suit as well. They're just 2 concepts that seem to work well together to potentially achieve this mission.
Apart from the suits, what else do we still need to work out before we can go to an asteroid and do something useful?
I'll let Stan explain that. He's the one playing with the tools today.
Oh, there's all sorts of things. For instance, from lessons learned, this is Steve's and my second run in this suit. Last time we learned that if you try to use a geologic hammer in a spacesuit, where your work envelope's right in front of your faceplate, that's not really a very good idea. So we still have a lot of room for improvement on tools. And then I guess the biggest unknown for going out and doing a spacewalk on a captured asteroid is what the asteroid is going to be like. The small asteroids that we could go and get with the robot ship are tiny. They're, a few yards across. Mm-hmm. And even in the world's finest telescopes, they're a dot. So you may not know till you get there whether you're dealing with basically a pile of sooty gravel that's loosely held together by its own weak self-gravity, or it could be a solid chunk of nickel iron. And the way you would move around on those, the way you would take samples from them are completely different. And at this point, we just don't know what we're getting. So we're kind of exploring what we can here in the pool so that on the real day we can have a better chance of doing it correctly.
And that's exactly why we do it. Stan and Steve, I really appreciate you taking a couple of minutes to talk to us. It's fun to do that and to see what you're working on there. Good luck.
Thank you.
Thank you.